Welcome to everybody to this lunch talk. Thank you for joining in spite of the rush before the summer holidays. And special thanks, of course, to Pawel Oclon, who is a professor at the Institute of Thermal Power Engineering at Cracow University of Technology in Poland. The floor is yours. Thank you.
Thank you very much, Professor Martin, for your kind introduction. My name is Pawel Oclon, and I would like today to present the lecture, RESHeat system for heating, cooling, and domestic hot water production for residential buildings. At the beginning, I would like to tell a few words about the RESHeat system. The idea behind the RESHeat project is to develop a zero-emission and autonomous energy system, which is based solely on renewable energy sources. And RESHeat is an energy regeneration system, which allows to produce electricity, heat, and cooling for residential buildings as well as commercial. In our project, we have the following concept. We have sun-tracked photovoltaic panels, PVT with cooling, so PVT modules. We have sun-tracked solar collectors, and we have also underground storage tanks, which are used to store the excess of heat from sun-tracked PV panels or sun-tracked solar collectors. As well, we also have boreholes. And why we are using these underground storages? First, to collect the excess of heat from sun-tracked solar collectors, and also excess of the heat from sun-tracked photovoltaic modules. This one, sun-tracked photovoltaic modules, produces the low temperature heat and 35-40 centigrades, and sun-tracked solar collectors produces the heat around 60 centigrades. So from the first one, we are storing the heat in the non-insulated storage tank, which is exchanging the heat with the ground. And the second one, sun-tracked solar collectors, we are using to charge this underground heat storage tank. When those tanks are charged and temperature reach 35 centigrades for the non-insulated and 60 centigrades for the insulated, we are also using the excess of the heat to charge the borehole heat exchangers, boreholes, to make the ground regeneration. It allows us then to supply the heat to the heat pump with the highest possible temperature. We can select one of those tanks or the boreholes to get, for example, 15 or 20 centigrades at the source side of the heat pump to allow high heat pump COP. Therefore, less electrical energy is needed to power the heat pump. It's also why we are using cooling for photovoltaics. As we know, with the excess of when the temperature of the PV panel surface exceeds 25 centigrades, then we have the drop of the efficiency. It's 0.45% per 1 centigrade. So to avoid it, we are using the heat from PV panels cooling to store it in the ground or to charge the boreholes. And this kind of system, why it's important is also that it is highly efficient because it uses the sun-tracked mechanisms. So both solar collectors and PV panels are sun-tracked. So this allows to achieve high efficiency with a small area, as well as by this ground regeneration, we are able to maintain the high coefficient of performance of the heat pump in the subsequent consecutive heating seasons. Therefore, this is also many times a problem that we are charging the heat from the ground without ground regeneration, and then the COP of the heat pump is decreasing in consecutive heating seasons. We are trying to avoid this situation by using the ground regeneration. Also, what are the main project objectives? The main project objective of the RESHeat is to cover at least 70% of the annual energy demand for multi-family residential buildings from renewables, to demonstrate the actual performance, including also economic performance of the system, and provide the end user with the information of the overall performance of the system. The third objective is to demonstrate of the system scalability for different types of multifamily residential buildings. 3 demonstrations plans are planned. We have completed in Limanowa, Poland, in Krakow, Poland, and now we are doing the demonstration on the suburb of Rome in Palombara Sabrina for multi-apartment buildings with 9, 13, and 24 apartments, respectively. In addition, the system will be also modified, that it also works efficiently to produce the cooling, and the tests will be made in Italy. Also, in the project, we need to make the economic efficiency assessment, life cycle analysis, and environmental impact assessment of the system. So the main objective of the project is to move the system from technology readiness level 7 to 8 and allow its commercialization. The project is funded from Horizon 2020 funds in the program of building a low-carbon, climate-resilient future, secure, clean, and efficient energy. The total amount of funding from European Union, 4.2 million euro, and the consortium consists of the following partners. The Cracow University of Technology is a project coordinator, and I am a project manager. We have also cooperation with leading European research institutions like Sapienza University of Rome from Italy, which is doing the part of Italian demo site, Brno University of Technology from Czech Republic, which is helping us in dissemination as well as in LCA and eco-cost analysis, as well as companies from small, medium enterprises sector, like Oilon from Finland. They are producers of the heat pumps. Chamara company from Poland, which is a system integrator and major commercializing partner, as well as Elfran Franciszek from Poland company, is from Nowy Targ. This company, southern Poland, they are producing this sun tracking solutions, and the demonstrations will be carried out or are carried out in various buildings. We have the users, Municipal Buildings Management Board in Krakow, and Ater Provincia di Roma from Italy, as well as private developer Top Caesar in Limanowa. So this will be the places where the demonstrations are made. And here I'm presenting the project implementation for the development and design. Those 3 universities, Cracow University of Technology, Sapienza University of Rome, and Brno University of Technology, are responsible for development and design of the project, of the demos. Elfran company, Oilon, and Chamara are responsible for system components. Elfran is responsible for these sound tracking solutions, Oilon for the high temperature heat pumps, and Chamara is responsible for underground storages, as well as system integration. The system will be, if the project finally succeeds, the system will be commercialized, and the major partners will be Elfran, Chamara, and Oilon, because they are selling those products. And it will be, we have also end users like municipal buildings of Krakow city, authorities, and other provincia di Rome, where we are able to make demonstrations in Poland and Italy into different climates. So at the beginning, I would like to tell a few words about Suntract PVT panels with cooling. Here on the right side, we can see the photo with the heat exchangers, YouTube heat exchangers on the backside of the PV panel. They were designed by Cracow University of Technology in a cooperation with ELFRAN within the HISOL project, which was Poland-German call, to reduce the temperature of the PV panels, as well as to be able to get as much heat, receive as much heat as possible. So this kind of cooling segments, like we can see, for example, here, are placed on the backside of the PV panels. And this solution is possible to be used for different types of PV panels. It is universal. And we have tested it in the district headquarters of the State Fire Service in Oświęcim in Poland. Also, ELFRAN company has an extensive experience in design, construction, and installation of solar collectors, PV and PVT modules. Here are some realizations: Suntract PVT panels, Suntract solar collectors, like ELFRAN Revolutions, and those photos are from another project which we have completed, SOPSAR project. It's funded by National Center for Research and Development of Poland, where the Chamara company was the major beneficiary of it, and ELFRAN delivered the sun tracking systems, but we were also helping in design. And these photos are from HISOL project. This was the project, the bilateral Poland-German project. We were doing the cooling system for PV panels. We compared stationary PV panels, shown here, with Suntract PV panels with cooling. It's shown here. The installation is made on the roof of this building. And the goal of it was to check what is the difference between those two solutions, and also deliver the electrical energy to the heat pump, which was used as one of the sources for building heating. What we were able to see from our experimental investigation, here we have the information about the electricity production for and the heat yield for stationary PVT panels and Suntract PVT panels. These PV panels with cooling system, which we have designed during the project. And what are the major benefits of using this sun tracking system is that by directly following the sunlight, we are able to achieve around 34% more electrical energy than in case of stationary PVT panels, as well as we are able to achieve 85% more heating energy, low temperature heat 35 to 40 centigrades, compared to stationary PV panels. So sun tracking mostly gives us more heat, and little bit less electrical energy, but still 34% more. And with these developments, we have done the first implementation of the system, which is similar to RESHeat. We had implemented it in the headquarters of Chamara company in Limanova. The system consisted of 102 PVT panels, 4 Suntrack PVT panels with 4 kilowatts electrical power output, as well as 10 Suntrack solar collectors. We had also here underground storage tanks and borehole heat exchangers to see how this system operates in the real conditions. The heat was and electrical energy is being delivered to Chamara company office building as well as the factory. Here are the photos from the implementation. Suntrack PVT modules, Suntrack solar collectors, as well as stationary PVT. Here we can see the energy storage tanks, heat storage tanks, which were placed here underground. So what are the results of our investigations? The heat pump COP of the system, yearly average, we were able to achieve over 5.6. It was also because the building uses floor heating, which allows 35 temperature of the load side for the heat pump, what is very favorable in case of COP. In our demonstrations, which we are completing now in Krakow and Limanova, unfortunately there is no floor heating. We have only radiators or fan coils in Italy. The reason is that the goal of this project was to demonstrate the system, implement the system in existing buildings, which are not new buildings with not very new heating solutions. We need to replace them with RESHeat system. Here we have the view of the building, of which is owned by Municipal Buildings of Krakow City in Działkowa. The building was built in 2013. It has 24 apartments, and the heating is natural gas boiler. So here we have one building, and there we can compare it with another building, which will which has a gas boiler, and then we can compare the costs and of the energy used and check how our system works. So here are the solutions which we proposed. Suntrack solar collectors with 30 kilowatts of thermal power output, PVT modules on Suntracers, stationary PV panels, high temperature heat pump, and underground heat storage 50 cubic meters. The issue is like this, that due to the limited land size, we are not able to install there two tanks, but this should be sufficient, this 50 cubic meters. And here are some photos from the installation: PV panels, Suntrack solar collectors, as well as the tracking system and Suntrack PVT, as well as the heat pump installation, underground storage tank, which is insulated here with the 50 cubic meters capacity, and oil-on heat pump. Here we have the photographs on drilling of the boreholes, 15 boreholes, 100 meters deep each. It was quite challenging because when we made this installation, there were some cell flows which significantly, which were quite problem for us, but fortunately the company was able to finalize it as it's in the project. And here are the actual photos, the Suntrack solar collector, PVT panels, Suntrack solar collectors, and PV panels on the roof, as well as facilities inside. Here we have also shown the demo installation in Limanova, which we have completed recently. Here is this underground storage tank for Limanova. Because there are good ground conditions, we are using a non-insulated tank. Also, we are using 5 Suntrack solar collectors, oil-on heat pump, Suntrack PVT panels. This is installation for 9 flats, which should operate quite well. And here are more details of the capacity of the installation on the solar collectors, PVT modules, heat pump, and underground storage. We will, here I'm showing also some photos from the installation of the system. And here we have the SCADA system to monitor the RESHeat installation in Limanova, as well as detailed photos of the underground storages, heat pump installation. And now what I would like to show, we have also performed some calculations to, we were validating our concept by using the Transys simulation software. This software allows to model the building heating demand, as well as to model renewable energy used within the building for building heating. So first of all, we developed the model and tried to validate the heat losses of the building and compare this modeled and actual energy consumption. So we validated the model, comparing real data and the simulated data, which were quite comparative for Transys and measurements from the building. Also, for making this model validation, we were using the data of the oil-on company, provided us some heating curves and efficiency curves for heat pump. We then adjusted the model. Also, we made this validation for other components like Suntrack PV panels, stationary PV panels, and Suntrack collectors, and underground storage. Fortunately, we were able to do it because we had data from our previous installation in Limanova, made during the SOPSAR project, which were led by Chamara company. And here our simulation shown that it's possible to achieve the yearly average heat pump COP over 4, which is quite good for us, as well as we are able to deliver about 42 megawatt hours of heating from Soundtrack solar panels, as well as the remaining of the heat will be delivered by the heat pump. So our when having the heat pump COP over 4, there will be needed around 20 megawatt hours of heating delivered by the heat pump. So our electrical energy produced allows us to cover it with a significant margin. And here we have the graph of PV and PVT electrical energy production, which shows us that, of course, in our case, the PVT panels will produce some part of this electrical energy, but also very big contribution will have the stationary PV panels. And here we have the simulation of the underground storage tank, which allows us to show how it will work during the heating season. And the RESHeat project is an opportunity to small, medium enterprises for the energy transition, because, for example, here we involve companies from Poland and Finland to cooperate between each other to deliver their solution and to provide a demonstration. We hope for further commercialization of the system after those demo sites will be fully operational. The system also enables the scalability, because we can do it for smaller buildings and bigger. Of course, the highest benefits are for bigger buildings, because the investment cost of the system are rather high, but we can get payback in a relative short time because of saving the electrical and thermal energy. And this is also an alternative to RESHeat is also an alternative to conventional heating system for building using fossil fuels, where gas piping or district heating networks are not possible or viable. And what is also important, actually, we are not sure about the prices of the gas, about the prices of the electricity. So we should use as much as possible the renewable energy with heating energy storage that will allow us to be independent and allow us to deliver both heating and electrical energy to the buildings. And I would like to thank you for your attention. It was a big pleasure for me to be able to present to you our project, which we are doing with the partners from around Europe, Project RESHeat. After this, I would like to also mention the names of the projects mentioned here. HISOL, which was funded by National Center for Research and Development of Poland. SOPSAR is also a project which was funded by the National Center for Research and Development of Poland and allowed us to make the first prototype for Chamara company factory and office building, as well as the RESHeat system is a project which we are continuing, and it was presented during this presentation. Thank you very much.
Thank you very much for this very interesting talk.